Hello everyone! Today we'll be introducing our multi-day tour exploring the famous attractions of Hong Kong. Aiming to revive the heavily hit tourism industry ever since the COVID-19 pandemic, we created an optimal path linking up tourist attractions from all around Hong Kong using the Bellman-Held-Karp algorithm. With different factors raised to a different power based on their importance, it works best in balancing traveling time and energy level required for activities. In our model, the duration spent at the destination is also taken into account. A QR code to our report and a corresponding page number is attached on each slide so you can easily follow along. The following assumptions are made to simplify our model. First, we have excluded the waiting time for the ferry. The tourists will travel to Cheung Chau by taking the ferry from Central Ferry Pier. The ferry trip will take 60 minutes. We have also assumed that when we travel from one attraction to another, there is no traffic on the road and the traveling time is minimal. The means of transportation is by car, except for the trip to Cheung Chau. Lastly, as our information is extracted from Google Maps, we have assumed that the information provided is accurate.
To form an interesting and engaging tour that allows tourists to explore the various aspects of Hong Kong, we have considered the following factors. Firstly, the shorter the traveling time between the two places, the better the route. This is because time taken to travel implies the cost of the route and the distance between the two attractions. Next, the more contrasting the two activities are, the better the route. Since it will be very boring to arrange similar activities consecutively, we have mixed diverse activities together such that different people can enjoy different types of activities in the tour. Lastly, the comfort of tourists is also very important. We would like to maintain the mean of the energy required for the two activities as close to the optimum level, 3, as possible, so that they will be energized enough to enjoy all of the activities planned each day.
We have defined the energy level required for an activity to be SI. We have also denoted each location with a letter from A to P. Feel free to pause the video if you would like to read the tables for values of each variable. Next, the time taken to travel between places is denoted by Tx to Y. Thirdly, the duration spent at a place is denoted by Hi. Lastly, the total hours spent on the tour each day is denoted by On, and the weight of the path between places is denoted by Wx to Y.
By repeating the nearest neighbor algorithm with different starting points, we can find the approximation of the best path, which may not be the shortest path in existence. The program is attached here for reference. We have also considered using the brute force algorithm, but quickly found that our computers are not powerful enough to generate all possible paths. Therefore, we integrated modern technology and computer science into computing the shortest path to save time. We have used the Bellman-Held-Karp algorithm, which is a dynamic programming algorithm, to find the shortest possible path. The steps used for generating the shortest path are included here for reference. The program is also attached here for reference.
For the mathematical model, we first took the traveling time into account. Although it maximizes efficiency, similar activities are arranged together and the schedule would be boring and tiring for tourists. Then we took the energy level required into account. The model puts different tourist attractions together so that tourists get maximum enjoyment. However, attractions from the same area are separated and attractions with energy level 3 are being organized consecutively, causing boredom.
Lastly, we raise different factors to a different power based on their importance. This is the optimal model as it puts different kinds of tourist attractions together so that tourists can get maximum enjoyment without sacrificing the traveling time between destinations. Comparing the two models, the regression surface of the 3D scatter plot of the second model has a more exaggerated curvature, while the one we just mentioned has a milder curvature, especially in the middle part of the regression surface, suggesting that it is less sensitive to the closeness of the mean of the two energy levels to 3, and more sensitive to the difference between the two values. In the original model, some pairs of values share the same factor multiplying traveling time. However, in the new model, the output is almost distinct for all distinct pairs of values. The smaller range of C will also mean that the model will be more sensitive towards the traveling time,
which solved the problem that tourists will be traveling constantly to and from districts when there are other tourist attractions nearby.
This project has aroused our interest in math modeling. We put to use the knowledge we learned from ICT and math lessons to use computer programs to generate the optimal path. We also learned how to use Google Sheets to generate weights and organize our data.
While we had fun completing this project, especially when brainstorming tourist attractions along the route, we encountered hardships when organizing workload and discussing abstract mathematical concepts online. Fortunately, we managed to solve these problems by updating each other periodically on our progress.
Special thanks to Google Maps for providing us with our information. This is the end of our presentation, and if you would like to sign up for our tour, you can either scan the QR code and email thebesttouraroundhongkong@gmail.com or dial 778-330-2389. We thank you in advance for your enthusiastic support. Until next time!